Welcome everybody to my topic, that reactive intermediates carbene and nitrene. We are discussing about the generation of the carbene. Among that generation of carbene, we have started to discuss about the diazomethane, because on decomposition of diazomethane it can generate the electronically neutral species, that is the carbene. So, last class we were discussing about the preparation of methyl ester from a carboxylic acid to its corresponding methyl ester using the diazomethane. Okay. So, we have seen that once this carboxylic acid is there, first this diazomethane will pick up the acidic proton, and that will actually generate this carboxylate anion, and once that will generate, it will actually react with the extremely unstable diazonium cation, that is the CH3N2 plus, and this carboxylate anion actually can work in SN2 mode and give this substitution reactions to give this methyl ester. Okay. And here this nitrogen will eliminate, and this compound is extremely unstable compound. Okay. So, now in these reactions, this carboxylic acid in presence of diazomethane, it can generate the methyl ester of that corresponding carboxylic acid. Now, if we see, let us say phenol, okay, will it be possible to make its corresponding methyl ether using this diazomethane? So, if we use diazomethane over here, then actually this proton is acidic enough, its pK is around pK of this particular proton, that is the around this hydrogen is around 10. Okay. So, now this is sufficiently acidic, so that this diazomethane that can react with that in similar mode of fashion. That means, here also you can write like this, it can pick up this, because this phenolate anion that is stable and this one is pretty acidic, this hydrogen. So, it can pick up this one and generate corresponding okay. So, rather I should draw like this way, like previous way, and this can attack over there and give you the corresponding this is called anisole. So, from phenol to anisole you can easily prepare in presence of diazomethane. But will it work if we use in spite of this phenolic compound if it is aliphatic alcohol. That means, I am talking about ROH when R is aliphatic. As per example, let us say we have this alcohol and we treated with diazomethane, will it work? But actually it does not work. Why? The reason is very simple, that is, if you see its this hydrogen pK, that is around, here pK is around 16. All these aliphatic alcohols, this type of alcohols is around this particular 16 approximately, and this is not acidic enough, so that this diazomethane can pick up that particular proton to give this corresponding anion. So, in this case, when it is aliphatic alcohol, these reactions will not work. Okay? So, what is the basic fundamental criteria here? That this corresponding hydrogen has to be acidic, okay, so that it can be picked up by this diazomethane and give this extremely unstable diazonium compound or diazonium cation, so that this corresponding anion, in case of in carboxylic acid it is the carboxylate anion, in case of phenol it is the phenolate anion, they can react with this extremely unstable diazonium species to give its corresponding methyl ester or methyl ether. Okay. Sorry. Now, we will see one example where both these aliphatic as well as aromatic alcohols are present. Okay. So, this is the corresponding steroid molecule. The name of this molecule is called Oestrel, OS, Oestrel, and this is a steroid moiety. Okay. So, now if this molecule react in presence of diazomethane, what will happen? As we explained previously, that this particular molecule contains two different type of OH group, one is aromatic, that is phenolic type, another one is aliphatic type. So, definitely this particular in this OH group, here this is more acidic, this phenolic OH. So, it will definitely it will react and give you the product like this. Okay. So, what we will get? We will get the corresponding methyl ether, and here the interesting thing is that here both of these hydroxy groups they does not work, they remain intact. Okay. So, in this case only this particular hydroxy group that will react and give the methyl ether. Okay. Now, why we are actually doing so many reactions with the diazomethane, or we are trying to learn the chemistry of diazomethane reactivity? Because the photolysis of this diazomethane actually produces carbene. Okay. One of these precursor for generating this carbene is the diazomethane. So, in principle we have diazomethane and this photochemical decomposition actually give its the corresponding carbene, okay, with the elimination of this nitrogen. It is a very stable molecule nitrogen. So, that will generate this carbene species. Okay. But as we have discussed in my previous class that diazomethanes as a carbene precursor, even though it is very much useful, but in lots of cases we found the generation of this type of diazomethane is very tricky. Why? Because these are having lot of limitations. As per example, this type of this compound is extremely toxic and can be a potential explosive, and as well as in the reactions that has to be taken care with very carefully with extreme caution. So, there are many limitations. Okay. So, another one is that always you have to keep it like in a solution, its boiling point is pretty less. So, these kind of limitations made these diazomethane use of diazomethane as a carbene precursor quite limited. So, having this having such limitations, people have started to thinking about diazocarbonyl compounds for the carbene precursor, okay, because the diazocarbonyl compounds are more stable compounds. So, handling of these compounds will be much more easier. Okay. So, once this is more stable compound, so what I am talking about? More stable. So, diazocarbonyl these compounds will be more stable. Okay. So, now if something is more stable, that means what we can do, that we can easily handle them, or the use of these diazocarbonyl compounds in the reactions will be easier. Okay. So, now why this is stable? Why this is stable? Why this is stable? If you see, the structure of these diazocarbonyl compounds is something like this. Okay. Now, this could be in resonance like this. So, okay. So, here electron withdrawing carbonyl groups that stabilizes the diazodipole. So, what stabilizes this diazodipole? Electron withdrawing carbonyl groups okay. So, electron withdrawing carbonyl groups that stabilizes the diazodipole. Okay. So, this actually triggers the stability. Okay. This will stabilize, okay, stabilize the diazodipole. Fine. So, overall these diazocarbonyl compounds are more stable than the diazomethane. So, obviously, we can use these diazocarbonyl compounds as a very good precursor for the carbenes. Okay. Now, we will learn the synthesis of these diazocarbonyl compounds, because these diazocarbonyl compounds on decompositions will give you the more stable carbenes. Fine. So, we need to know the synthesis of these diazocarbonyl compounds and their possibility to form the carbenes. Okay. So, let us see that the synthesis of diazocarbonyl compounds. So, okay. So, what we will start with, that first the reactions of acyl chloride with diazomethane. So, reaction of acyl chloride with diazomethane. Okay. So, what is acyl chloride? So, if you take the carboxylic acids and you treat with thionyl chloride or oxalyl chloride, so that will give the acyl chloride. Now, you treat it with the diazomethane. Okay. So, now it will react to give you the corresponding diazocarbonyl compounds. Okay. What is its mechanism? Now, if you will have this acyl chloride, now you have diazomethane. So, this can easily react over here, and once this will go, so will come back and this will go out. So, what it will form? This will form as, so RCO, just putting 2 hydrogens like this CH2 one, and then the corresponding N2 plus, and once you have this, then again one more molecule of this diazomethane, that will picked up this acidic proton. Okay. So, once it will picked up, so okay. So, now this will have the corresponding diazocarbonyl compounds. Fine. Now, what it will generate from here? It will give actually this extremely unstable CH3 N2 plus, this one, and we have from here this chloride minus, that will react over here and give the corresponding nitrogen eliminations, and methyl chloride, they are gaseous. Okay. So, overall we can generate our desired diazocarbonyl compounds in efficient way. Okay. So, what is the starting materials here? The acyl chlorides and diazomethane, and that will react to give you this diazocarbonyl compound. Okay. Now, in another method where the parent carbonyl compound will react with tosyl azide in presence of base, that will also give you the corresponding diazocarbonyl compound. Okay. As per example, So, reaction with tosyl azide and base. Okay. So, what will be the, this is the parent carbonyl compound. Okay. So, the corresponding diazotransfer reagent is tosyl azide here in presence of base like triethylamine. So, the diazo exchange will happen. Okay. So, diazo exchange and the product is our desired diazocarbonyl compound. This one, okay. And the byproduct is the corresponding sulfonamide, okay. Here, and I think you know already that structure of tosyl azide. How does it look like? Para-toluene, tosyl is para-toluene sulfonyl. Okay. So, para-toluene sulfonyl azide, fine. Now, in another method for the preparation of these diazocarbonyl compounds, people have used that alpha trifluoroacetyl derivatives of the ketone to prepare its corresponding diazo derivative. As per example, so here we can write reaction of alpha trifluoroacetyl derivatives of ketone. So, for example, we can take the corresponding ketones. Okay. So, if we take this ketone and then in presence of some base, strong base, as for example, lithium HMDS, and this ester CF3CO2 CH2 CF3, and number 2 is that the for the diazo exchange, that is the methane sulfonyl azide in presence of base, okay, that will give this corresponding diazo compound in a very efficient way. Okay. So, these type of substrates that can also first in presence of base, the anion will generate and that will pick up this corresponding from the ester, that will react with this, and finally, the diazo transfer will give you the desired diazocarbonyl compound. Okay. Next, what we will see, now we have all these diazocarbonyl compounds. Now, how we can generate the carbenes from these? So, our main target was to generate the carbene, or our topic of the discussion here was the carbene generation. So, to know that we have first learned these kind of diazocarbonyl compound synthesis. Now, we will try to find out how these diazocarbonyl compounds actually convert into its carbene. Okay. So, let us see the carbene generation. Okay. So, these are the carbenes that we have generated. Okay, fine. Now, under thermal or photochemical decomposition, this will give the corresponding carbene plus nitrogen. Now, what drives this kind of carbene generations? What is motivating for such kind of decompositions of these diazocarbonyl compounds to generate the carbene? We see that generation of nitrogen, that is the one of the most stable compound, that drives or forces for the for such kind of decomposition to generate these kind of carbenes. Okay. So, this generation of the stable small molecule is very important for preparation of these carbenes. Okay. In another example, it is a very important one, because in this case we will use, in place of heat or photochemical decomposition, we will use the corresponding transition metal to generate the carbenes. So, let us see how it works. As per example, we have this diazocarbonyl compound, and in presence of this rhodium 2 complex, it generates these carbenes, or rather I should say that it stays like here L equals to ligand. Okay. This is actually called not rather carbenes, but these are called, in another term, this is called carbenoid. So, what is carbenoid? Carbenoid also similar type of species like carbenes, but in that case it is actually partially bound to other atoms. Okay. So, carbenoids are the species that also reacts in a similar mode of fashion like carbenes, but in general that partially bound to some other atoms, that is called carbenoids. Like in this case, it is bound to this transition metal rhodium, and this is called that carbenoid species, but they react in similar mode or similar fashion like carbenes. We will in many occasions we will show that this type of carbenoids are generating during the reactions, and that actually reacts in similar way like carbene works. Okay. Our next carbene generation will be the carbenes from tosyl hydrogens. Okay. That is all for today. Thank you.